Hello friends, welcome back to C level physics. My name is Srinivas, known to be BS Rao. In this lecture, I would like to explain some results based on equations of motion. Okay, now see here some results are written on right on the top here. First one, S of 1 is to S of 2 is to S of 3 is to up to S of t equal to 1 is to 4 is to 9 is to t square up to t square. S of 1, S of 2, S of 3 in the sense distance covered in 1 second, in 2 seconds, in 3 seconds, in t seconds up to so on. Okay. Now in second result, s of x 1 is to s of x 2 is to s of x 3 is to up to s of x n equal to 1 is to 3 is to 5 is to up to 2n minus 1. Here s of x 1, s of x 2 up to s of x n means distances covered in successive seconds. Okay, here distance is covered in 1 second, 2 seconds, 3 seconds, etc. But here particular second, in first second, in second second, in third second up to so on. Right? Now coming to third result, the difference in distances covered for a uniformly accelerated particle is numerically equal to its acceleration. Okay. Now in fourth result, suppose A and B are 2 points at which you are given velocities of particle VA and VB for uniformly accelerated particle. Okay. Now, what is the velocity of the same particle midway of those 2 points? Means V mid equal root over VA square plus VB square divided by 2. Now, in fifth one, S of n divided by S of x n equal n square by 2n minus 1. Here, S of n in the sense distance covered in total n seconds, but S of x n in the sense distance covered in nth second, particularly in nth second. That equal n square by 2n minus 1, where n is the total number of seconds in which particle is under motion. Okay, now let us see one by one. First one, see, we know that result number 1. What is that result? The distance covered in total t seconds, s of t, that is s equal to ut plus half at square. What is this one? S equal to ut plus half at square means one of the basic equations of motion. Am I right? Where u is the initial velocity, t is the total time of journey, and s is the distance or displacement covered, where a is constant acceleration. Okay. Now here s means s of t. I am writing s of t. S of t in the sense distance or displacement covered in total t seconds, not tth second. That is in total t seconds. Am I right? Now say u equal to 0 and a is constant. U equal to 0 in the sense particle just starts from rest and moves with constant acceleration. When particle starts from rest in the sense initial velocity is 0. When particle comes to rest means final velocity is 0. Am I right? But here particle starts from rest in the sense initial velocity is 0. Okay. Now substitute there s of t equal to u means 0, that is 0 plus half a square, that is half a t square, half a t square. S of t equal to half a t square, where a is constant, therefore half also constant. S of t is proportional to t square. In case of a ratio, that is s of t equal to half a t square. Here is equal to is there. Okay, if I remove half into a, that is constant term, we left with s of t is directly proportional to t square. Right? Now, if you want to get the ratio of distances covered in first second, in 2 seconds, in 3 seconds, etc., simply replace t by writing 1, 2, 3, etc. That is s of, therefore s of 1 is to s of 2 is to s of 3 is to up to s of t is equal to, what is the ratio? Here 1 means take 1 in case of t, that is 1 square. 1 square is to, now this time 2. T means 2, that is 2 square is to, next t means 3, that is 3 square is to up to what is the final value, that is t square. So therefore what is the final answer? 1 is to 4 is to 9 is to up to t square. Okay, if t is replaced by n, up to n square otherwise. Okay, now this is what the ratio of distances covered in 1 second, in 2 seconds from the beginning itself, in 3 seconds from the beginning itself, in t seconds from the beginning itself. So distance covered in 0 to 1 second is to 0 to 2 seconds is to 0 to 3 seconds is to 0 to t seconds is given by 1 is to 4 is to 9. Okay, now coming to second result, that is S1 is to S2 is to up to so on. Means the ratio of distances covered in successive seconds, especially in first second, in second, not from 0 to 2 seconds, in third second, not from 0 to 3 seconds. So is given by 1 is to 3 is to 5 is to up to 2n minus 1. So we know that distance covered in nth second, that is S suffix n, is given by u plus a by 2 into 2n minus 1. 2n minus 1, where u is initial velocity, a is constant acceleration. Alright. Say u equal to 0 and a is constant. So path starts from rest and moves with constant acceleration. Right. Now replace therefore S suffix n means distance covered in particular nth second is given by, what is the answer? u0 means we left with a by 2 into 2n minus 1. A by 2 of 2n minus 1. Again, a is constant, 2 also constant, a by 2 once again constant. So therefore, S suffix n is proportional to, remove this constant term a by 2, we left with 2n minus 1. 2n minus 1, right? So this is what the distance covered in, especially in nth second, is directly proportional to 2n minus 1, where n is particular second. Right, here S of t is proportional to t square. Here S suffix n is proportional to 2n minus 1. If at all n is replaced by t, S suffix t is proportional to 2t minus 1 also. Right? Now let us see the ratio of distances covered in successive seconds. That is S suffix 1 is to S suffix 2 is to S suffix 3 is to up to S suffix n is given by. Now say S1 in the sense replace n by writing 1 in this expression, that is 2 into 1 minus 1. So 2 into 1 minus 1. First term over. In second term, S suffix 2 means replace n by writing 2, that is 2 into 2 minus 1. 2 into 2 minus 1 is to, next case, this time replace n by writing 3, that is 2 into 3 minus 1. 2 into 3 minus 1 up to, what is the final step? That is S suffix n. S suffix n in the sense 2n minus 1. So 2n minus 1. Okay, now what is the final answer? That is equal to 2 into 1. 2 minus 1 means 1. 1 is 2. 2 2 is 4. 4 minus 1 means 3. Here 2 3 is 6 minus 1 means 5. Is to up to 2n minus 1. So this is what the ratio of distances or displacements covered in successive seconds for a particle which starts from rest and moves with constant acceleration. Okay, now here this is what in fact the ratio of distances covered in successive seconds, in first second, especially in second second, especially in third second, in fourth second, not 4 seconds, in fourth second, in fifth second, etc. That is 1 is to 3 is to 5 is to up to 2n minus 1. Of course, this is what the ratio of distances covered in successive seconds. Successive second in the sense in first second, in second second, in third second, etc. Now what is the time interval here? Exactly 1 second. Okay. Now time interval from 1 to 2 means 1 second. From 2 to 3 also 1 second. From 3 to 4 also 1 second. Means this relation not only valid for successive seconds. Of course, it is valid for successive equal intervals. Successive equal intervals, however small or large these intervals may be. For example, one particle is under motion for 24 hours. Okay, which moves with zero initial velocity and moves with constant acceleration. Now, in that case, what is the ratio of distances covered in every hour? That is, in first hour, in second hour, in third hour, in fourth hour, in fifth hour, in sixth hour, up to 24th hour means once again 1 is to 3 is to 5 is to up to 2n minus 1. Right? Okay, suppose one particle is under motion for 60 minutes, whose initial velocity is 0, whose acceleration is constant. In that case also, now what is the ratio of distances covered in successive minutes? That is in 1 minute, in first minute, in second minute, in third minute, in fourth minute, also same is the answer. That is 1:3:5 up to 2n minus 1. So what is the inference here? This ratio is not only valid for successive seconds, of course it is valid for successive equal intervals, however small or large these intervals may be. Okay, right? Okay. The next result here. Suppose we know that s of t equal to ut plus of a t square. U means initial velocity, t means total time of journey, a means acceleration. Right here, u is not equal to 0, but a is constant. Say u is not equal to 0 means initial velocity is not equal to 0 means at time t equal to 0, particle possesses some initial velocity and moves with constant acceleration. Okay, now I want to describe distances covered in consecutive equal time intervals. Consecutive equal time intervals means what should be the ratio here in case of u equal to 0? In case of u equal to 0, this is what the ratio of distances covered in successive consecutive time intervals 1:3:5 up to so on, provided u 0, but here u is not equal to 0, but asking the distances covered in successive equal time intervals. For example, in first 2 seconds, now what is the distance covered? Let it be s1. S1 equal to u not equal to 0 means definitely that should be there with the expression, that is ut plus 1/2 of at square. See, 1:3:5 up to so on, right? So 1/2 of at square. In next 2 seconds, this is what distance covered in first 2 seconds. Now distance covered in the next 2 seconds also, s2 equal to ut plus half into, that is 1/2 of at square. After 1, what is the value here? 3. 1:3:5 so on. So second value, that is 3. 3 times half at square. Right? Now distance covered in next 3 seconds, t seconds, that is s3 equal to again ut plus, after 3 what is the value? 5. 1:3:5, that is 5 into half at square. Right? Up to so on, s suffix sn equal to, right, in last t seconds. In last, it doesn't mean that distance covered in nth second. This is distance covered in last t seconds, not tth second, last t seconds. That equal to ut plus n into, sorry, 2n minus 1. 2n minus 1. See last value, that is 2n minus 1. 2n minus 1 into half at square. Half at square. So this ultimate value ut plus 1/2 at square means ut plus half at square. Here ut plus 3/2 at square. Here ut plus 5/2 at square. Here ut plus 2n minus 1/2 into at square. So this is what successive distances in successive equal intervals, provided u is not equal to 0. So every expression we have first term ut involved, here also ut involved, here also involved, here also involved. Okay, that is third result, that is sn minus 1 equal to a. So what is the expression for sn? Sn equal to u plus a/2 into 2n minus 1. So distance covered in particularly in nth second, that is u plus a/2 into 2n minus 1. Okay, right? Now what is sn minus 1? Means distance covered in previous second, that is in n minus 1th second. So distance covered in n minus 1th second, that is in previous second, equal to u plus a/2 into 2 into, is it n or n minus 1 here? N minus 1. It's not n. If it is n, here also n. If it is n minus 1, here write In case of n, n minus 1, that is 2 into n minus 1, 2 into n minus 1, 2 into n minus 1 minus 1, minus 1, right? That is u plus, so 2 to cancel, 2 to cancel, that is a into, take 2 inside, that is 2 by 2 cancel, otherwise 2 into n minus 1 minus 1 by 2 here. So that is equal to u plus a into, here what is the value, 2n minus 2 minus 1 by 2. That is what, u plus a by 2 into 2n minus 3, 2n minus 3. So we have Sn and Sn minus 1. Now take the difference, Sn minus 1. So Sn minus 1 is equal, what is Sn? This is Sn, that is u plus a by 2 into 2n minus 1 minus Sn minus 1 means this is the Sn minus 1, that is u plus a by 2 into 2n minus 3, 2n minus 3. So on extending, u plus, what is the value here? What is the value? 2 to cancel, an, we left with an, plus or minus minus a by 2. Here u plus 2 to cancel, we left with an, minus 3 times a by 2, 3 times a by 2. So on extending, u plus an minus a by 2 minus u minus minus or plus minus an minus or minus plus 3a by 2, 3a by 2, am I right? That is plus a and minus n cancel, plus u minus u cancel, left with 3a by 2 minus a by 2. 3a by 2 minus a by 2 means 2a by 2, that is a, that is equal to a. So Sn minus 1 is numerically equal to a, is numerically equal to a, that is this is what the difference in distances covered is numerically equal to acceleration, provided particle moves with uniform acceleration, uniform acceleration. For example, in fifth second distance covered equal to s5 equal to 10 meter and s6 is equal to 12 meter. Now what is acceleration of particle? Suppose one particle moves with uniform acceleration, right? What is the distance covered in fifth second? 10 meter. What is the distance covered in 6th second? 12 meter. Now find acceleration. Find acceleration. How to get acceleration? A equal to, say, Sn minus 1. Sn minus 1. Distance covered in particular second minus distance covered in previous second. That is, what is the distance covered in 6th second? That is 12 meter. What is the distance covered in previous second? That is 5th second, 10 meter. That is 2. So 2 meter per second square. 2 meter per second square. Okay. Now coming to next result. What is that result? A equal to Sn minus Sn by n minus n. Suppose this time I am writing here Sn minus 1. For example, suppose I am writing Sn minus 1 divided by n minus 1, right? So n minus 1 means denominator n minus 1. See here, distance covered in n second minus distance covered in n minus 1 second. Now I am taking denominator like that, n minus of n minus 1. N minus n means cancel, minus or minus plus 1, that is 1. So Sn minus Sn minus 1 by n minus n minus 1 means nothing but Sn minus 1 by 1. N minus n cancel, minus or minus plus 1. So which is equal to Sn minus 1 is equal to Sn minus 1 is equal to what? Acceleration. Similarly, suppose we have distance covered in n second and distance covered in n second, for example. Say, suppose distance covered in nth second minus distance covered in mth second divided by, see this order, here n is there, n minus 1 is there. Same only taking in denominator, that is n minus 1. Here n is there, here m is there. So take same in denominator, that is n minus m. Sn minus Sm by n minus m, which is equal to what? Acceleration. Which is equal to acceleration. Right? For example, S9 equal to 10 meter. Distance covered in 9 seconds, 10 meter for example. Distance covered in 15th meter, that is 75 meter as an example, 75 meter. Now what is the acceleration of the particle? What is the acceleration of particle? Suppose that particle is under uniformly accelerated motion. We have two distances. What are the distances? In 9th second and 15th second. But particle is under uniformly accelerated motion. Now, based on this relation, now see Sn minus Sm by n minus m equal to A. Similarly here, S15 is greater than S9. So I am taking S15 minus S9 by 15 minus 9. Sn minus Sm by n minus m. Okay, for the sake of symmetry, here n, here m, here also n, m. If it is m, m minus n also, right? So S15 minus S9 by 15 minus 9, right? That is equal to acceleration. Now what is the answer? S15 means 75. 75 minus S9 means 10. By 15 minus 9 means what? 15 minus 9 means 6. That is what? Acceleration. So 75 minus 10 means 65 by 6. 65 by 6 meter per second square. That is what? Acceleration. Okay. Now fourth one. Velocity at midpoint is given by so and so. Let us see. This is what point A. This is what point B. At point A, what is the velocity u? Let it be VA. At point B, what is the velocity of particle? V. Final velocity, that is V. Particle moves with constant acceleration as an example. Now total distance, let it be S. Suppose here one more point is there, midway of A and B. That is what C. Now from A to C, what is the distance covered? S by 2. From C to B, S by 2. Now what is the distance from A to B? S by 2 plus S by 2. That is S. Total distance from A to B, S. From A to C, S by 2. From C to B, S by 2 means C is midway of A and B. Now find V at C. That is V mid. Right? Now divide the diagram into two segments. AC is first segment, CB is next segment. Right? So take the one of the kinematic equation, that is V square minus V square equal to AS. For this segment, this is what initial velocity, VC is the final velocity. For this segment, VC is the initial velocity, PB is the final velocity. So for A to C, this is initial velocity, this is final velocity. So V square minus V square equal to AS. So what is the final velocity? VC. That is VC square minus what is the initial velocity? UA. That is VA. Equal to into A into what is the S? Distance covered S by 2. Number 1. right? Number 1. For segment C to B, for segment C to B, second segment, next half of the segment. So velocity of C is the initial velocity, VB is the final velocity. Now take again the same expression, V square minus V square equal to AS. What is the final velocity? This is the final, this is the initial. So final VB square minus U means VC square equal to into A into what is the distance covered from C to B? Again S by 2. 2A S by 2. Number 2. So 2 cancel AS. Here 2 cancel AS. So what is RHS here? AS. Here also AS. So from 1 and 2 RHS same equal LHS. So from 1 and 2. Here LHS what? VC square minus VA square equal to, here LHS means VB square minus VC square. VB square minus VC square, right? That is VC square minus VC square. Carry this minus VC square to LHS, that is it becomes plus VC square equal to, take this minus VA square onto RHS, that is VA square plus VB square. VB square is there, right? This is what VB square. Now 2VC square. 2VC square equal to VA square plus VB square, right? Now VC square equal to, now VC square equal divided by 2. Now VC means VC. VC in the sense velocity of particle at C, which is equal to velocity at midway of A and B. That is V midway of A and B is given by root over. See, this is what VC square. I am taking VC, VA square plus VB square by 2. Am I right? For example, here particle moves with constant acceleration. At A, what is the velocity? 10 meters per second. At B, what is the velocity? 20 meters per second. At midway, C, V mid. Find velocity at midway of A and B. Now see this result. V midway equal root over VA square plus VB square by 2. So V mid equal to root over VA square plus VB square by 2. VA square plus VB square by 2 under root. That is VA square. VA square means 100. 10 square means 100. Plus VB square means 20 square. That is 400 by 2. Right? 100 plus 400. 500 by 2 means 250. So root 250. Root 250 meter per second. That is 5 root 10. Root 250 means 5 root 10 meter per second, right? So next result, that is S of n by S of x n equal to n square by 2n minus 1. We know that, see next result, that is number 5. We know that S of n equal to S of n, otherwise S equal, what is S equal to? Ut plus half at square. We know this result, alright? S equal to ut plus half at square. This is what distance or displacement covered in t seconds. So I am writing S of t instead of S. I am writing S of t. S of t equal to ut plus half at square. If t equal n, same can be written as S of n equal to un plus half a n square. Replace t by writing n. Where what is t or n? Total time of journey. Total time of journey means in seconds as an example, right? S of n equal to n plus half n square means n means total time of journey seconds, right? Now what about S of x n? We know that this what? Suppose say u equal 0, a is constant. U equal 0 and a is constant means particle starts from rest. Starts from rest means take u equal 0. So therefore S of n equal to here 0 means 0 plus something means 0. So we left with half a n square. of an square. Right? Similarly, s suffix n. What is the expression for s suffix n? That is s suffix n. We know that s suffix n means distance covered in nth second. S suffix n equal u plus a by 2 into 2n minus 1. U plus a by 2 into 2n minus 1. Say u equal to 0. Say u equal to 0 and a is constant. And a is constant. Right? U equal to 0 and a is constant. U0 means particle starts from rest and moves with constant acceleration. That is s suffix n becomes 0 plus a by 2 into 2n minus means a by 2 into 2n minus 1. Number 2. Right? Now 1 divided by 2 implies 1 divided by 2 implies what is 1? S of n divided by what is s suffix n? What is 2 here? S suffix n. S of n divided by s suffix n is equal to here of a n square divided by here a by 2 into 2n minus 1. A by 2 into 2n minus 1. So a by 2 cancel. We left with s of n by s suffix n is equal to n square by 2n minus 1. n square by 2n minus 1. So distance covered in n second upon distance covered s of n upon s suffix n. So distance covered in n seconds upon distance covered in nth second is equal to n square by 2n minus 1, where n is the number of seconds in which particle is under motion. Okay, now let us see one example based on this result. What is that result? Suppose one particle starts from rest and moves with constant acceleration of 10 meters per second square. Right? If it covers 9s by 25 meters, in the last second, in the last second of journey, right? Find the time of journey and distance covered and total distance covered. Yes. Total distance covered, yes. See here, in the last second of its journey, what is the distance covered by the particle? 9s by, see here, 9s by 25. Where, what is s here? Total distance covered. So if s is the total distance covered in total seconds, but especially in the last second, that is in nth second, it covers 9 by 25 times of total distance. And particle starts from rest and moves with acceleration 10 meters per second square. Right? So we need to find total time of journey time, total journey time and total distance covered. So here we have one relation, s of n by s suffix n equal n square by 2n minus 1. Okay, n square by 2n minus 1. Now see answer solution, that is s of n by s suffix n equal to n square by 2n minus 1. S of n means total distance covered in total seconds. What is the total distance here? S. So total distance S divided by total distance in total seconds, that is s divided by, what is the distance covered especially in nth second, that is 9s by 25. 9s by 25. 9s by 25, which is equal to 9s by 25, which is equal to n square by 2n minus 1, where n is total journey seconds. Total journey seconds. It may be 10 or 9 or 8, etc. Whatever it is. Let us see what will come out. So s by 9s by 25 means ss cancel. 25 goes up. That is 25 by 9 equal to n square by 2n minus 1. Take cross multiplication, that is 9n square. 9n square is equal to 25 times 2n minus 1. 25 into 2, 50. N minus 25 into 1, 25. That is, what is the final solution here? 9n square. 9n square minus 50n plus 25 is equal to, you compare with ax square plus bx plus c equal 0, implies x equal, what is the solution here? X equal minus b plus or minus root over b square minus 4ac by 2a, right? So here a means 9, b means minus 50, c means 25, x means n. So instead of x, we can take n equal to minus b means minus 50, plus or minus root over b square means minus 50 whole square, minus 4 into a means 9, into c means 25, by 2 into a means 9. So which is equal to n equal to minus or minus plus 50 plus or minus root over 2500 minus 4 into 25, 100 into 9, 900 by 80. Right, that equal to 2500 minus 900 means 1600. 1600 under root means 40. That is 40. So 50 plus or minus 40 by 80. So n equal to either 50 plus 40 by 18, that is 90 by 18, 5 seconds. Otherwise, n equal to 50 minus 40. Here 50 plus 40, here see plus or minus. So go with other relation also. That is 50 minus 40 by 18. 50 minus 40 means 10. 10 by 18. 10 by 18 means less than 1. So less than 1 second. Less than 1 second. Less than 1 second. See, we have distance covered in nth second, means in last second. In last second itself, 9 by 25 times total distance. We are given distance covered in the last second means, what does it represent? The time of journey must be greater than 1 second. Why? Because we have information of distance covered in the last second. Now what about previous seconds? Last second means 1 second. What about previous seconds? Definitely total time of journey is greater than 1 second. So this is what, if you go with this relation, n equal to 50 minus 1, negative, if you go with the negative sign, then you will get n is less than 1 second. So this is wrong option. If you go with positive sign, n equal 50 plus 40 by 18, that is 5 seconds. So n is 5 seconds means definitely greater than 1 second. Okay, so this is what correct answer. So total time of journey means 5 seconds. Now what is the total distance covered? S equal to ut plus half h square. S equal to ut plus half h square. So total journey time. So therefore total journey time t equal to n equal to 5 seconds. Now what is the total distance covered? S of t equal to ut plus half at square. So u0, s of t means n, that is not 5, s of 5. Total distance covered in 5 seconds, not 50 seconds, 5 seconds. that is equal to half into A. A means what? 10 meter second square acceleration. 10 into T square. T means 5. So 5 square. 5 square. That is what? 5 5 ja. 25 into 10. 250 by 2. 125. S of 5 equal to 125. 125 meters. 125 meters. This is what? Distance covered in total 5 seconds. Okay.